In Chapter 4.3, we'll learn how to find the vertical and horizontal translations of sine and cosine functions, identify the phase for sine and cosine functions, and graph a sine or cosine function having a horizontal and vertical translation. In general, the graph of y equals f of x plus k is the graph of y equals f of x translated k units vertically. If k is a positive number, the translation is up. If k is the negative number, the translation is down. If we add the term to the argument of the function x, the graph will be translated in a horizontal direction instead of a vertical direction. However, keep in mind, then if this part is negative, then the graph is going to shift right, h units. If y equals fx plus h is positive, then the graph is going to shift left h units. Let's graph y equals sine of x plus pi over 2 if x is between negative pi over 2 to 3 pi over 2. Because we haven't graphed an equation of this form before, it is a good idea to begin by making a table of values. For x equals negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Here are the values of y. And we're going to plot these points on the graph. The blue graph represents the regular shape of y equals sine x. The red graph represents the shifted graph. And we can see it shifted negative pi over 2 units to the left, even though the argument changed by plus pi over 2. We can see why the graph was shifted to the left by looking at how the extra term affects the basic cycle of the sine graph. We know that the sine function completes one cycle when the input value or the argument varies between 0 and 2 pi. In this case, our argument is x plus pi over 2. Subtract pi over 2 from both sides, we get negative pi over 2 on the left. Subtract pi over 2, we'll have to find common denominator, times 2, 4 pi, minus pi, 3 pi over 2. Let's go back to the two graphs. Notice that the cycle will now begin at x equals negative pi over 2 instead of 0. And will end at 3 pi over 2 instead of 2 pi. Because it shifted pi over 2 units to the left. Let's now combine all the knowledge that we learned previously about the graphs of sine and cosine functions and graph y equals 4 cosine of 2x minus 3 pi over 2 for x between 0 and 2 pi. Begin with identifying the amplitude. The amplitude is equal 4. There is no vertical translation because no number has been added or subtracted from the cosine function. We determine the period and horizontal translation from a basic cycle. One cycle of our graph would be from 0 to 2 pi. Here's our argument. So we work our way to get x by itself. Add 3 pi over 2, add 3 pi over 2 to both left and the right side. Get 3 pi over 2 on the left, 2 pi, multiply by 2 over 2 to get the same denominator, 4 pi plus 3 pi is 7 pi over 2. Then we need to divide by 2 or multiply by 1/2 since we're dealing with the fractions. To get x by itself, on the left side we have 3 pi over 4. On the right side, we have 7 pi over 4. A cycle will begin at x equals 3 pi over 4. So the horizontal shift is 3 pi over 4. To find the period, we can subtract the left and the right endpoints of the cycle. 7 pi over 4 minus 3 pi over 4 is pi. Or equivalently, divide 2 pi by b is 2, where the b is coming from the part 2x. So the period is 2 pi over b, or 2 pi over 2 equals pi. Dividing the period by 4 gives us pi over 4. To mark the x-axis, we begin at x equals 3 pi over 4, and we will add pi over 4. 3 pi over 4 plus pi over 4, the next will be pi. 3 pi over 4 plus 2 pi over 4, we do some math here, is 5 pi over 4. So the next increment is 5 pi over 4. And then 3 pi over 4 plus 3 increments, so 3 times pi over 4. Again, let's do some math and then simplify the end. Will be 3 pi over 2. And then finally, the last one is 7 pi over 4. Let's now connect the points of our frame. Our y is from -4 to 4 with the amplitude of 4. So we start at a 4. X is 3 pi over 4. And it's a sine function, not reflected about x-axis. So we start at 4, go down to pi, down to -4 at 5 pi over 4, another 0 at 3 pi over 2, and up to 7 pi over 4. And because the original problem asked for the graph on the interval from 0 to 2 pi, we extend the graph to the right by adding the first quarter of a second cycle. So we add one more increment and on the right, and 1, 2, 3 on the left to extend the graph from 0 to 2 pi. In general, for y equals sine of bx plus c, or y equals cosine bx plus c, to complete one cycle, the quantity bx plus c must vary from 0 to 2 pi. Therefore, assuming b equals 0, greater than 0, then we get, let's simplify, subtract c from both sides and then divided by b. Divided by b, we get x is from -c over b to 2 pi minus c over b. The horizontal shift will be the left end point of the cycle, or negative c over b. If you find the difference between the end point, you will see that the period is 2 pi over b as before. The constant c in y equals sine of bx plus c, or y equals cosine bx plus c, is called the phase. Phase is important in situations such as when working with alternative currents, where two sinusoidal curves are being compared to one another, if x represents time, then the phase is the fraction of a standard period of 2 pi that a point on the graph of y equals sine of bx plus c lags or leads a corresponding point on the graph of y equals sine bx. The period horizontal shift and the phase for sine and cosine functions. Overview. If c is any real number and b is greater than 0, then the graph of y equals sine of bx plus c and y equals cosine of bx plus c will have period that is equal to 2 pi over b, horizontal shift that is equal to negative c over b, and phase that is equal to c. Summarizing the information we have covered about the graphs of the sine and cosine functions, we can say that the graphs of y equals k plus a times sine of b x minus h and y equals k plus a cosine b of x minus h, where b is greater than 0, will have the following characteristics. The amplitude of a function will be a. The period of a function is 2 pi over b. The horizontal translation is h. And the vertical translation is k. In addition, if a is less than 0, then the graph will be reflected about the x-axis. Let's graph one complete cycle of y equals 3 minus 5 times sine of pi x plus pi over 4. First, rewrite the function by factoring out the coefficient of pi, because we can see that pi is here and here, so we want to factor the pi out. Factoring pi out will give us 3 minus 5 sine of pi x plus 1 over 4. What can we tell about this graph? We can tell that a is equal to negative 5, so the amplitude will be absolute value of negative 5, which is 5. The horizontal shift is negative 1/4. Therefore, the graph will be shifted left 1/4 unit. The vertical shift is 3. The graph will be shifted up 3 units. The period is 2 pi divided by b, coefficient of x, which is 2, which is pi. So 2 pi over pi is 2. Verify the period and horizontal shift, and to help sketch the graph, we examine one cycle. We remember that sine function is a cycle from 0 to 2 pi. We get the original argument and simplify till we get to x by itself. So we subtract 5 pi over 4, subtract pi over 4 from left and right side. In the middle we get pi over 4 is cancelled, pi times x. We have to do some math on the right. 4, so it will be 8 pi over 4 minus pi over 4, which is 7 pi over 4 on the right, and then multiply by 1 over pi times 1 over pi pi and pi is cancelled. We get negative 1/4 on the left. Pi and pi is cancelled. We get 7 over 4 on the right. So our cycle will range from negative 1/4 to 7/4. Dividing the period by 4 gives us 1/2. So our cycle is from 7/4 to -1/4, which is equal to 8/4 or 2 divided by 4 or times 1/4 will give us 1/2. So here's our frame. And see, our frame moved up 3 points because K, the vertical shift was 3, so the frame moved 3 points up, and also 1/4 to the left. Now let's draw the frame first, and then we'll plot the points. So we start from -1/4 plus 1/2, -1/4 plus 1 times 1/2 will give us, we're gonna do some math here, times 2/2, -1/4 plus 2/4 is 1/4. Here's our one segment. The next segment will be -1/4 plus 2 times 1/2, which will be -1/4 plus 1, -1/4 plus 1, or 4/4 with the denominator of 4, which is equal to 3/4. And then we do the same thing for the next segment, -1/4 plus 3 times 1/2, because now we have 3 segments, 1, 2, 3, and we get 5/4. Our function in this example is moved 3 points up and 1/4 to the left, and it also is reflected about the x-axis. So we will start at -1/4 and 3 at this point, then go down to our next point, up, here's our next 0, up to 8. I'm staying within the frame. Did you notice that? Here is the frame that we built to draw a graph. We're staying within the frame. If we need to continue the graph, then we can continue the graph. And here's our complete graph of y equals 3 minus 5 sine pi x plus pi/4.